Hi, today we discuss about scale drawings, chapter 4, maths, form 3. So what will you learn in this topic? So just one part only this topic, 4.1, scale drawings. So why do you learn this topic? Scale drawing are used to give an idea of object measurement or actual distances. Scale drawing are frequently used in architecture, engineering, photography, technological design, and so on. For example, you want to show somebody a model or any project that you have done. The actual size is too big. Then how can we show him on a piece of paper? We cannot just bring the model. It's too large. It's not practical for you to bring and show him. So sometimes we need to sketch. Okay, sketch the diagram. But when we sketch, we will have a scale for our drawing. We want the size to become smaller, or we want the size to become bigger, but still show the size which is proportional to the actual size. Okay, now we look at our topic 4.1. Okay, you can refer to your textbook. Okay, the first part we want to study what is the relationship between actual measurement, ukuran sebenar, and the measurement of various sizes of drawing, ukuran pada lukisan. So, apakah hubungan di antara ukuran sebenar dan ukuran pada lukisan untuk objek tersebut? Do you know that the maps found in navigation software are drawn to a certain scale? The distance between two towns shown in the software is proportional to the actual distance. So this is our country Malaysia. So how come the distance of 300 kilometer can just be drawn here on the map? Or on the screen of handphone, you can see the distance between Kuala Lumpur and Setiawan. That one is too long, nearly 300 kilometer, maybe more than 300 kilometer. So how can we draw it on the piece of paper or on this map? Meaning we use the concept of scale. Okay, for example, in the picture above, the distance between Johor Bahru and Kuala Lumpur is showing a scale of 1 cm equals to 5 kilometer. Meaning every 1 cm of your drawing is equivalent to 50 kilometer of actual distance. Okay, so this is your drawing 1 cm. This is the actual length or actual distance. Okay, look at example 1. Okay, the diagram below shows the drawing representing object PQRST drawn to different sizes. Okay, you can see the diagram. What can you say about diagram 1, diagram 2 and diagram 3 as compared to the object PQRST? So this is the actual object. Okay, solution. We will look at diagram 1. Lengths of all sides and sizes of all angles are same as the object. So you look at how we know whether same or not. Maybe just count the number of square here. PQ is 1, 2, 3, 4. And then the equivalent side here is also 4. And then PT 1, 2, 3, 4, 5, 6. Diagram 1 also 1, 2, 3, 4, 5, 6. And then ST 2. Here also 2. RS 4. Here also 4. QR also same length, coming from this triangle 2 times 2. So meaning the object and diagram 1 are equal in size. Okay, because the ratio of the side QP and this one equals to 1. So they have same size of all angles and side. Okay, diagram 2. Length of all sides reduces by certain proportion compared to object, but sizes of all angles unchanged. Look at this one, the actual one, and the second object. QP or PQ, PQ here is 4, here is 2, meaning reduced to half. PT here 6, here 3, also reduced to half. ST 2, here is 1, also reduced to half. RS here 4, and here also reduced to 2. So meaning for QR also same. Here coming from the triangle 2 times 2. Here coming from triangle 1 times 1. Meaning the ratio between the side for the object and the drawing is half. Okay, so meaning the size of the side for the object and the drawing are proportional to each other. Proportional. Meaning all reduced to half. Okay. Look at diagram 3. Length of all sides increased by certain proportion compared to the object. Angles unchanged. Okay, now we look at what happened. The PQ here 4. Here become 8. Means times 2. Double. Okay, PT here 6. Here is 12. Meaning also times 2. ST 2. Here is 4. Also times 2. RS here 4. Here become 8. So also times 2. And then this one for the QR here is 2 times 2 the triangle. Here is 4 times 4 triangle. Meaning all the sides are proportional to each other, and it become double. The size become double. Okay. So what can we say about all the diagrams? Okay, so we can say all sides of diagram 1, 2 and 3 follow a certain scale that is proportional to the object, whereas angle size remains unchanged. Therefore, diagram 1, diagram 2 and diagram 3 are scale drawing of object PQRST. So in order for you all to identify whether the drawing given is actually the drawing of the object, so you must check all the sides. All the sides must be proportion to each other. Either it become half, or it become double, or become triple. So meaning same proportion for all sides. So we call it, that one will become diagram 1, 2, 3 are scale drawing for object PQRST. Okay, scale drawing is the drawing of an object with all measurement in the drawing proportional to the measurement of the object. So that one we call it scale drawing. Okay, means all the side proportional. Look at Mind Test 4.1a. Look at the first question, number 1. The diagram below shows drawings representing object A, B, C, D, E drawn to different sizes. So this is the actual object. State the diagram which is the scale drawing of object A, B, C, D. So what you do, let's look at the first diagram. Side AB. Here 2, here is 3, meaning 2 over 2, the ratio is 2, 3. 2 to 3, the ratio. Here BC, ratio also 2 to 3. Here ratio 6, and here is 2, 4, 6, 8, 9. 6 to 9 also is 2 to 3, meaning AE also proportion. Okay, DE coming from the triangle 4 times 4. This one 8 times 8. Okay, how about this one? Can we get? Okay, this one also we get 2 to 3. Yeah? Here you can see the diagonal line. You can check. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 4 to 6 means 2 to 3 also. So diagram 1 is the scale drawing for this object. Okay, we'll look at diagram 2. Diagram 2 for AB, 2 become 1, meaning 2, 1 become half. Okay, BC also become 1, CD also become 1, AE also become half. 6 become 3. And then here 4 become 2. So meaning diagram 2 is also scale drawing for ABCD. Let's look at diagram 5. AB 2, here is 2. Yes, 2, 2. Okay, means 1, 1. BC 2, 4. So it's wrong already. Once you get one side which is not proportional to each other, then the diagram is not a scale drawing. Automatically we can say diagram 5 is not the scale drawing for the object. Okay, so just show one side which is not proportion to each other, then you can say that diagram is not the scale drawing for ABCD. Okay. Okay, you can continue and complete the exercise. Okay, number 2, using grid paper, draw all the shapes below using the same size. Okay, become same size. You just copy. The smaller size, maybe you divide to half. Okay, bigger size, maybe you times 2. Meaning the scale drawing is become bigger or smaller. It depends. Depends on the size that you draw. Okay, how do you interpret the scale of scale drawing? Okay, the scale used to draw a scale drawing depends on the ratio of measurement of scale drawing to the measurement of the object, which is scale, measurement of scale drawing divided by measurement of object. D divided by O, drawing divided by object. Okay, ataupun boleh juga cakap lukisan kepada yang sebenar lah, actual drawing. Okay, this ratio can also be written in form measurement of scale drawing to measurement of the object, meaning drawing to actual. Okay, lukisan kepada sebenar. Actually, for scale drawing, we use the scale in form of ratio, meaning 1 unit of scale drawing equivalent to what size of the actual measurement, where n is positive integer or fraction. Okay. Okay, this one you can just look at by yourself, interpret the scale of the scale drawing. Okay. Okay, you try to do the brainstorming one, and then we can make a conclusion based on your answer. If you get n smaller than 1, the size of scale drawing is bigger than the size of the object. If n more than 1, the size of scale drawing is smaller than the size of the object. If n equals to 1, then size of the scale drawing is same as the size object. So we have this scale, this formula. Scale equals to measurement of scale drawing divided by measurement of the object. Once we get the drawing and the object are proportional, or the side of proportion, then we can take one of the side of the scale drawing and one of the side, equivalent side, and the actual for the object. Then we divide 1 divided by n. Okay, or you get a fraction like 2 to 1. So you must make sure for the scale drawing you must change it to 1, because the way we write the scale must be 1 to n. Okay, example 2. Example 2. Diagram shows object PQRS and scale drawing P prime, Q prime, R prime and S prime drawn on a grid of equal squares. State the scale used in the form 1 to n. Okay, this is the object, this is the drawing. Okay, so how to get the scale? You can use the measurement on scale drawing. This is P prime, Q prime. If you use PQ, you can take, for the drawing is P prime Q prime, so divide by measurement of the object, okay, meaning PQ. So here is 2, here is 4. So 2 divided by 4. Okay, so you had 2 divided by 4. Then we write in the form of 1 to n, so we get 1 divided by 2. Or you can use another side. For example, you use PS. So this is the drawing. So P prime S prime divide by PS. Okay, so we have 3 unit here. Here is 6 unit. So 3 divided by 6. Right, in the form of 1 to n, you can simplify mathematically, meaning above and below you divide by 3, so you get 1 to 2. Thus, we can make conclusion that the scale for this drawing is 1 to 2, meaning 1 unit of the drawing is equivalent to 2 unit of the actual object. Okay, so actually the drawing is smaller than the actual object. So we have proved that for n more than 1, the size of the drawing is smaller than the actual object. So this one drawing, this is actual object, so it's smaller. Okay, look at diagram 3, example 3. The diagram below shows object KLM and scale drawing K prime, L prime, M prime drawn on a grid of equal squares. State the scale used in the form of 1 to n. Okay, again, the same thing you do. This is the drawing. This is the actual object. So take one side. If you use KL, meaning you refer to here KL also. K prime, L prime is the drawing for KL. Okay, so for K prime, L prime here, how many units? 1, 2, 4, 6, 8, 9. So 9. Then KL here is 1, 2, 3. Then the scale become, okay, measurement of the drawing 9 divided by measurement of the object 3. So 9 divided by 3, so we get 3, 1. Okay. Okay, never mind. Later we simplify. Or you want to use other side, like using LM. Same thing. L prime, M prime divided by LM. So we get 12 divided by 4, also 3 to 1. Thus the scale we get 3 to 1. But remember, we always write in 1 to n. So meaning here we want to change to 3. So what we do, we divide both sides with 3. Okay, divide both sides 3. So we get divide by 3. So you get here 3 divided by 3, 1. 1 divided by 3, 1 over 3. So meaning your scale for this drawing is 1 to 1 over 3. So this one we get n less than 1. If n less than 1, meaning the drawing is bigger than the object. So you can see here drawing is bigger than the object. Okay. Example 4. Let's say they give you the size of the grid 1 cm. Here 1 cm. So diagram below shows object PQR and scale drawing P prime, Q prime, R prime drawn on the grid of equal squares of different sizes. Determine the scale used in the form of 1 to n. Same thing, right? How we determine the scale? Okay, same thing. If you refer to P prime, Q prime, meaning you refer to PQ here. This is scale drawing, this is object. So now we use the size as centimeter. We don't have the size P prime, Q prime, but we have QR and Q prime, R prime. Okay. So what we do, we use Q prime, R prime divided by QR, then 6 divided by 3. Okay, here is 1 square is 2 cm, so here 2, 2, 2, 6. Here 1 cm, so 1, 2, 3. 6 divided by 3, 2 to 1. So we write the scale in form of 1 to n. So meaning here divide by 2 both sides. So both sides you divide by 2, then you get 1 to 1 to the power 2, or 1 to half. Okay. Another method is grid size of scale drawing, grid size of the object. Grid size is used because number of unit size drawing is the same. Okay, so we can use grid here 2 1. Okay, meaning here 1, here 2. So we also can write as 2 1 to 2 1, 2 to 2 1. Simplify, you get 1 to half. Okay, so this is scale for the drawing. Okay. Okay, example 5. Diagram below. Example 5. Diagram below shows object K, L, M, N and scale drawing K prime, L prime, M prime, N prime drawn on the grid of equal squares of different sizes. Okay, determine the scale used. So this is a bit different because they give you the size of the square. Okay, here object 1 square, the side of 1 square is 1 cm, here is 0.5 cm. Okay, now we want to calculate. Method 1, you can use K prime N prime divided by Kn. So 2.5 divided by 5, so you get 0.5 to 1 or half to 1. Scale half to 1, you convert to 1 to n. So meaning half divide by half or half times 2. We want to change this one to 1. If this side you multiply by half, meaning, if this side you times 2, meaning the other side also must times 2. Then we get 1 to 2. Okay? Or use grid size also can, 0.5 to 1. So you have same answer, 1 to 2. Okay? Example 6. A map is drawn to a scale of 1 to 300,000. Calculate actual length in kilometer of a river that is 3 cm long on the map. Okay? So we have given the scale already. So actual length of a river is 3 cm, meaning this is the drawing. The drawing. Okay? So we use the formula of scale. Scale is measurement of the drawing divided by measurement of the object. So equivalent to scale. Scale always written as 1 divided by n. So 1 divided by 300,000 cm. Okay, equals to measurement of the drawing 3 cm divided by measurement of the object or its actual distance. Then from here we can solve mathematically. You make it actual distance as the title of the equation. Then you can solve mathematically. So we get actual distance is 9 kilometer. Okay, or the other method, scale drawing, ratio of scale drawing to the object. So we have scale drawing 1, object 300,000. 1 cm, okay, represent 300,000 centimeter. So you want here is 3 cm. Both sides multiply 3 cm. So 1 times 3, 3 cm. 3 times 3, 9 cm. So the answer is also 9 cm. Okay. So it depends on how you solve it. If you understand this method, you know how to use the formula, you can use this one. If you understand the proportional method, so you can use also method 2. Okay, example 7. The map of Johor is drawn to scale 1 cm to 10 km. Calculate the actual distance between Kluang and Air Hitam if the distance of the map is 2 cm. So we use the formula of scale. Scale equals to distance on drawing divided by actual distance or object distance. So scale 1 to 10. 1 cm to 10 km. So 1 divided by 10 km. Equivalent to 2 cm. Here map 2 cm divided by actual distance. So actual distance equivalent to 20 kilometer. Or proportional method again. Scale drawing is 1 to 10 kilometer. For 1 cm is 10 kilometer, meaning 2 cm how many kilometer? So 1 times 2, 10 kilometer also times 2. Both sides must times 2. And 2 cm is equivalent to 20 kilometer. Thus the actual distance is 20 kilometer. Okay, example 8. Cairo draws a square to scale 1 to 1 over 3. If actual length of side of the square is 6 cm, what is the length of side in centimeter of the scale drawing? Okay, use the formula of the scale drawing. Okay, so scale equals to side of the scale drawing divided by corresponding side of the object. Drawing divided by object. Okay, so we have the scale 1 divided by 1 divided by 3, 1 over 3, equivalent to side of the scale drawing divided by 6. Okay, actual length, given here actual length yang sebenar, 6 cm. So we solve this one, we get length of the side of the scale drawing equivalent to 3 times 6, 18. Or proportional method again. Okay, the scale is 1 to 1 over 3. You want 18 you want it to become 6 cm on for the actual length. How do you want to make it 6 centimeter? Meaning 1 divided by 3 times 18. So you get 6. So this side also must multiply 18. So both sides must multiply 18. Then we get length of the side of scale drawing is 18 centimeter. Okay. Okay, you can try for Mind Test 4.1b. Determine the scale used for each scale drawing below in the form 1 to n. Okay, maybe you can try one here. This is the scale drawing. How many units? 1, 2, 4, 6, 8. Here, how many units is 4, meaning scale drawing 8 to 4. Then it become 1 to half. Okay, so you try to calculate this one. Try to right. Maybe you can draw again the diagram, then answer the question, or you can print out this one. You can photostate, paste into your book, and then answer the question. Okay, so that one is scale 4.1b. Yeah? Okay, that one number 1. So you can continue with number 2, number 3, and number 4. Okay, now the next part is about how do you draw the scale drawing of the object and vice versa. Drawing the scale drawing of the object, there are 3 ways to draw the scale drawing of the object. A. Use grid paper of the same size of different scales, or use grid paper of different sizes, or draw on a blank paper according to the given scale. Okay, so you have your exercise book all got grid line, so easier for you to draw. Just take 1 square equivalent to 1 unit or 1 centimeter. Draw the scale drawing of shape PQRS and grid of equal squares using the scale. Okay, 1 to 1 over 2. So the scale given is 1 to half. Therefore, every side of the scale drawing is 2 times longer than the length of side of the object. Okay. Remember, if n less than 1, the drawing is bigger than the object. So here 1 to half, meaning 2 to 1. 1 of the actual is 2 times for the object. Okay, so 2 times bigger. Okay. Example 10. Diagram PQR triangle, drawn a grid of 1 cm times 1 cm. Redraw triangle PQR on grid paper, dimension 1.5 cm times 1.5 cm and 0.5 cm times 0.5 cm. Calculate the scale used in A1 and A2 in the form of 1 to n. Okay, now you want to change the dimension. Here is 1, 1. You want to change to 1.5 times 1.5, and another one 0.5 times 0.5. So we want to draw the diagram. Look at the solution for this one. Okay, the first one, we change to grid paper, the size of 1.5 times 1.5. So we get this size. Okay. We change to grid 0.5 times 0.5, so we get this one. Okay, so you can check the size of the side. So the scale, we get grid size of the scale drawing 1.5 divided by 1. So we have 1.5 to 1. So here 1.5 divided by 1.5. Here also 1.5 divided by 1.5. That is equivalent to 1 to 2 or divided by 3. Okay. Or use this one also same. 0.5 divided by 1. So you get 1 to 2. Okay. Construct the scale drawing of triangle PQR using scale 1 to 2. Remember, we have discussed that for the side, the change of the side, size of the side, proportion to each other, the drawing and the actual object, and make sure angle also must be same. Angle same, angle cannot be changed. Only the side can be changed. It's proportional to each other. Okay. So you draw using the protractor, using a compass. You can create a line, a construction line to show how you draw the triangle PQR. The word construct here means you must show how you draw using compass and ruler. Okay. You want to draw below part. Okay, example 11. Okay, drawing object for scale drawing. This is example 12. Draw the actual object. You just twist the question, but you still use the same formula. So you can try to understand all the example and try to answer all the questions that given to you in the Google Classroom. If any problems, then we will discuss later. Okay, that's all.